So I got one of these Yihua 898Ds a few years back. At the time it seemed like a good option, as my Radio Shack iron was pretty much done with, and I wanted to try some SMD work with hot air. I have to say it wasn't a bad combination station for me at the time, but over time I did move to cartridge style irons. The hot air still works reasonably well, and a friend gave me a soldering tweezers that could be used with this station, so it was worth keeping around. But more recently I've started to have issues with the hot air cutting out randomly. All of a sudden the heater will no longer get power and the fan will turn off shortly after. Meanwhile, the temperature displayed on the screen will not change, as if the station thinks it's still up to temp. Thinking it could have been a problem with the thermocouple, I replaced the heating element and the thermocouple, which are a unit, come together, a couple years back, and things seemed to be okay for a while, but then the problem started again, sometimes occurring many times in a row while trying to get something done. Quite annoying. So now comes the point where the station will either be fixed or tossed, and a new, higher quality one will be had. So, I had a look in this before, so if I remember correctly, you can see what's going on. This is transformer's warm, which is interesting, but because I wasn't using the soldering iron, which I thought the transformer relied on, but also all the logic relies on the transformer, of course. Couple 3-digit 7-segment displays right here and here. We have the microcontroller. We have two LM 358s, op amps, a couple trimmer pots. We have, let's see what these parts are. Tip 122, BT 137, and a BT A12. We have some zero crossing detection here, or actually the MOC 3041, that is triac driver, so that means this is probably going to be the triac driver. These op amps would be for measuring the temperature of some thermal couples. Some full bridge rectification here. Alright, so unfortunately this is a single-sided board, so it's easiest to kind of make a transparency with it here, and then I was able to make a schematic mostly complete except for kind of the display stuff, which was behind the display chip, which was behind the displays, and that's pretty straightforward anyways. Just read the data sheet. It's the display chip was a let's see where it is here, a TM1628. So if you're familiar with the TM kind of 16XX series, it's pretty straightforward. So they do the push button and the display with that. So let's see, here we have, here's the microcontroller. This is all mirrored, so it's going to appear mirrored. So we have the kind of the bottom 4 pins here, which I guess are, here's pin 1. So this is going to be, let's see, 10, 11, 12, 13, 14. So then the purple are the op amp inputs for either hot air and soldering iron. And then we have the triac drivers. There are 2 triacs, one for the hot air and one for the soldering iron. And if we follow those, one just goes up here through a couple resistors. Then you have the triac driver, isolated triac driver chip. You got the triac up here. you have the top header. This header is for the hot air. This is where the hot air handle gets its power. It's switched by the triac. Then you have, I think the incoming power here comes in, goes out to the transformer. And then we have the other triac driver, just a NPN transistor. I believe it was a, where is it? I believe it's here. So yeah, here it is. And this is, I think, a 2N3904 NPN transistor. They seem to use a few of those. And there's what looked to be a 3901, which I couldn't really find too much on, but I think it's basically the same as a 3904. So you have that driver for, here's the triac, the second triac. The soldering iron triac is the, where is it? It's the BT137 for the triac, for the soldering iron, and then the one for the hot air is the BT12-6008. There's the schematic for that. Then you come down here. You have the blue 24 volt AC winding from the transformer here. And then you have a 4-pin header, one ground. Oh, it's actually a 5-pin header, sorry. This is not populated. The middle one is not populated though. So you have a ground, then you have the thermocouple input, the other side of it. Then you have the heat that is, or the power that's switched on and off by the triac for the soldering iron. Then we move over. Here is the hot air op amp. All the op amp stuff, the inverting and non-inverting is in yellow on this diagram. So we have the op amp inputs and ground, and this this green is actually the handle detect. So the handle detect goes here, so it knows whether the handle's on. So these are kind of all just sensors. They're just the two sensors, the temperature sensing and the handle sensing. And then the op amps are here. Here's one. This is the inverting and non-inverting for the first op amp and the LM358. It's for the this one here, right over the header for the soldering iron, is for the soldering, or for the hot air. Is the hot air amplifier, and then this one up here is the soldering iron amplifier. So what they do is they run in the non-inverting input here, and then they have kind of a feedback, adjustable feedback with the potentiometer here for the inverting, and then that is actually, the output is actually run to the non-inverting output for, well, it'll probably be easier to see in the next schematic, but it's all here. I'll probably put this on GitHub or something if anybody needs, if anyone has problems with their station, would like to try to fix it. But anyways, let's just go through a couple components, I suppose. Basically here you just have the logic power. You have, I think, 12 volts AC and 33 volts AC. And here's a 7805 linear regulator here. And then the other diodes, there's a set of, I guess, 5 diodes here, go to the, this whole area is the fan control section here, which actually I don't think is correct. Where is it? I don't think this is correct. It doesn't seem to make sense. So I might have to go look over this again, at least maybe the components. Maybe one of these is actually a PNP transistor. So, but anyways, there's a 30 volt winding for this hot air fan controller, because I guess it's a 24 volt blower in the fan. So this is the tip 122 that controls the power for the fan for the hot air, and here's the header for the fan for the hot air. And let's see, up here we have the headers for the soft on for the soldering iron and for the hot air. And this is actually pulled up here because this is actually pin 4 and this is actually a reset pin, so I guess they have to pull it high. This may be internally pulled high with an internal resistor, I'm not really sure. So that's basically it. Alright, we're making a little progress here. We have the scope hooked up now. We have the op amp. We're probing the op amp output for the thermocouple for the hot air gun, and we're also probing the pin that drives the triac. Purple is the triac driver. So what we see is that the driver line is high, and it's using a driver chip, and when it goes low, that actually it is sinking current, and that'll light a bulb in the isolated driver chip, and it'll enable the triac. And then this yellow line is the op amp output for the hot air. So as the temperature goes up, the voltage will increase slowly, and we'll see that. So let's take it off its handle there, and we can see that the purple line dropped and the other line's going up, and it's set to around 300, and then we start to see some PWM once it reaches the temperature that it's supposed to be at. And it's actually fairly stable op amp voltage there, which is nice. I'm gonna have to look into the schematic a little bit more for the op amp and see if there's anything I can learn from it. Anyways, this is when it's working, so if it would only just exhibit the problems that it was exhibiting earlier, that'd be nice. I think what happens is, I think it just stops being driven. I don't know. I thought maybe the op amp, maybe I could observe something on the op amp that would cause it to go into some kind of shutdown mode, but we'll have to see. It's working this time, so I'll just let it run and see if it ever stops working. I have you here. Well, it's actually working. We can look at the startup and shutdown behavior as far as the driver is concerned for the triac. So we take it off its handle, and we can see the voltages for the op amp. Well, the temperature is held pretty well according to the op amp voltage. Of course, we could probably zoom in and see some more variations, but so we see the PWM, and then as soon as we put it back on its handle, you can see that the triac turns off and the op amp voltage slowly drops until at a certain point the fan also stops. So it cools down the coil before it turns the fan off to a pretty low value, which is maybe unnecessary because it was just much more. Oh, look at that. It's actually going up after the fan goes off, which, makes sense. So maybe they're onto something. All right, so here we have the handle opened up. Ball of wires, a little board here. So we have the AC right here coming in. Then we have just the earth ground, the fan, negative and positive, and a sensor, ground, another sensor for the handle. So this is going to be the thermocouple. And then we have this other sensor tied to ground as well, which is this guy right here, a little reed switch. You can see there. Let me zoom in a little bit. So this tells the system whether it's on the handle or not. Let's just put it. Okay, so no continuity. Camera, here we go. Here's a magnet. So no continuity. Continuity. So it's a pretty flimsy switch. Just soldered in there like that. I think I may just keep it. It doesn't seem just a much better solution that I could work out. Just hope the wires don't break off. Okay, so really there's nothing in here that's gonna cause a shutdown. So put this all back together. I desoldered the fan. Have to resolder that. But it was worth a look because I wasn't sure what some of these wires going into here is. So I'll probably take a picture of this for reference and close it back up. All right, making a little progress. Next thing to check was the soft on switch that we have here, and this soft on is connected to the microcontroller up here. And you flip the switch, it tells it, hey, you know, turn on the hot air, or the other one is for the soldering iron. So right now it's soldering, or the hot air is on. If we push down on this, it thinks it's on. So there's some sort of issue with how it's connected. And if we observe it on the scope, we can see the blue channel is that switch, one contact to it, and it's kind of noisy. There, it just switched on to off. I moved it a little bit, switching on to off, you know, and I'm not, you know, doing much. So, and it'll actually exhibit the behavior that it was exhibiting if I mess with this probe a little bit. So we take the heater off, the hot air off. 350, the light's blinking indicating power. We mess with this, all of a sudden the power's cut. It just has kind of reset, because and then it goes into cool down mode, but it's not the type of cool down mode that is when you put the handle back, because that'll gradually show decrease in heating. Now you can see it stopped. We're still reading 350. But there's no heat, no fan, no nothing. It's been reset. So the problem is something is kind of finicky with this line. It may be some loose connection or something like that. Another interesting thing is the soft on for the hot air is actually the reset pin on the microcontroller. So it doesn't seem as though the microcontroller is being reset, although it could be, because the display is actually controlled by a separate chip, and if the display chip doesn't lose power, it may just continue displaying the same number or data that it did before. So the whole chip could be resetting. Not exactly sure, but we're going to go look into that a little bit more. It may just be a loose connection. You can see I just touch it and it just completely resets. So it's looking just like a loose connection, and it's most likely resetting the whole chip or just resetting toggling the switch on and off. Let's take this off so we don't accidentally bump it. Okay, so then let's turn it on. And then let's quickly toggle that. Look at that. If we quickly toggle the switch, it does the exact same thing. So it's actually just the switch is being toggled. Okay. All right, let's holster it. We'll turn it on. Unholster it. Let it get up to temp, and then we'll toggle the switch. And so off, on, and see what happens is it shuts off again. So basically the soft on is the loose connection that's being toggled. Anyways, that seems to be the issue. It was not some complicated op amp or triac driver issue or handle cradle issue or anything like that. Got to look at everything, I guess. Alright, so we're reassembled and appears everything's working. We have the power on, we have the switch here for the hot air. Turn on the hot air switch. Shows you what the temp is. We take the heater off. Let it get up to temp. 350. And we can go and flick this and nothing's happening, so that's a good sign. So I just kind of shored up the connections. I basically took a pliers and just made sure that the connections were all tight. And I also soldered where the wire connects to the connector. I soldered that, so if there was anything there, it is now seems to be fixed. So now time to reassemble. And I mean, I could have done it with the soft on for the soldering iron too, but that's not broken, and you know, when that breaks, we'll just have to fix it, I guess.